Good morning to all of you. Today we are going to handle the subject engineering mechanics. The subject code is G8292. This video lecture presents the problems based on triangle law and parallelogram law of forces. Okay, actually we will apply this triangle law and parallelogram law, both these laws, when two forces are acting on a system with respect to some angles to each other, and we can easily find out the resultant magnitude and direction. Let's go to the slide. Now we can solve a problem based on these two methods. I read out the problem first. Find the resultant of the given forces by parallelogram law and triangle law. Okay, there are two forces given. One is 3 Newton force and the other one is 4 Newton force, and they are acting at right angles to each other. That is, the angle between the two forces is 90 degrees. Okay, let's move on to the problem. Actually, the first method we are going to solve is by parallelogram law. So you know the resultant equation, that is for by parallelogram law, r is equal to root of p square plus q square plus 2pq cos theta. So in that you can apply, instead of p and q, you can apply 3 and 4. Okay, and the angle between the two forces, that is theta is 90. Okay, now we apply in that equation, that is r is equal to root of 4 square plus 3 square plus 2 into 3 into 4 cos 90. So you will get the answer as 5 Newton. That is, the resultant magnitude is 5 newtons. Okay, then you want to find out the direction of the resultant, that is alpha, that is mentioned in this problem as a. Okay, so tan a is equal to q sin theta divided by p plus q cos theta. Okay, so that is the formula. So you apply that relation, that notations, p, instead of p you apply 4, and instead of q you apply 3, and instead of theta you apply 90. So in that equation, in that alpha, that is a equation, you get a is equal to, that is the angle of the resultant, that is the direction of the resultant, a is equal to 36.87 degrees. Now we solve the same problem by using triangle law method. Actually, in triangle law, we should first of all form a triangle, then only you can solve the problem. Okay, so the problem is mentioned here. The 3 Newton force is acting vertically upwards in the left hand side, and the 4 Newton force is acting horizontal, and it is positive direction at angle 0. Okay, and to form a triangle, if you see the diagram as per given in the problem, actually they 4 Newton force and 3 Newton force are acting along different directions, that is not in same order. But for a triangle law, you should that A and B force, that is 3 Newton and 4 Newton force, should be in same order, so that the resultant will be the third side in opposite order, but it is not satisfied. So we can graphically move the 3 Newton force from left side to the right hand side, that is without changing the magnitude and direction of that 3 Newton force. We are moving the 3 Newton force from the left hand side towards the right hand side as per the diagram 2. Okay, given here. So the 3 Newton force comes here, so then the resultant will form the third side. So when this 3 Newton force come to the right hand side of the 4 Newton force, automatically they become, the 3 Newton force and 4 Newton force will become in the same order. So if you close that resultant R, you will get the triangle. Now we can apply both the cosine law and sine law here for getting the magnitude of the resultant and direction of the resultant. First we apply the cosine law rule by for determining the magnitude of the resultant, that is R is equal to root of a square plus b square minus 2ab cos theta. So in that you apply all the things, you get r is equal to 5 newtons. Then you want the resultant angle, that is a. So for here you apply sine law. So here you require only that resultant angle a. So you require only two terms. So you apply r by sine 90, that is the opposite angle, is equal to 3 by sine a. So simplifying this, you get the value of a as 36.87 degrees. Now we can move to the problem number 2. Okay, so I will read out the problem first. Find the resultant of the given forces. So first by parallelogram law method, and second by triangle law method. Here the forces given are 50 Newton and 70 Newton. The angle between the two forces is 60 degree. In the previous problem, the angle between the two forces was right angle, that is 90 degrees. But here the angle between the two forces is 60 degree. So we can follow the same method. Number 1 is parallelogram law method. So you know the equation that r is equal to root of p square plus q square plus 2pq cos theta. So you apply that instead of p you apply 50, instead of q you apply 70. You will get the resultant magnitude as 104.4 newtons. Okay. Then for determining the angle of the resultant, that is direction of the resultant, you have the formula q sin theta divided by p plus q cos theta. Okay. So there you apply instead of P you apply 50, instead of Q you apply 70, you will get that is A. Here alpha is termed as A, okay. So you get A as 35.5 degrees. That is the direction of the resultant. That is resultant angle is 35.5 degrees by method 1, that is parallelogram law of forces. Then we can go for the second method, triangle law method. So you first of all draw the diagram as per given in the problem. 50 Newton, 70 Newton, the intermediate angle is 60 degrees. It is acting upon 60 degrees, okay. Now these two forces, 50 Newton and 70 Newton force, are not in the same order, okay. It's in different directions. So in order to form the same direction, we are moving the 70 Newton force from the left hand side towards the right hand side without changing the magnitude and direction, okay, without affecting the system, okay. Automatically now the 50 Newton and 70 Newton force becomes in the same order, so that the third side is closed as per in the diagram 2 in triangle law. That is the resultant, which will be in the opposite order, okay. Now you can apply the cosine rule for determining the magnitude of the resultant. You know R is equal to root of a square plus b square minus 2ab cos theta, okay. Actually the interior angle, the angle between the two forces becomes another 120, because so when you move from the 70 Newton force from the left hand side towards the right hand side, the 60 becomes the exterior angle. So 180 minus 60 becomes 120. So interior angle becomes 120. So we are changing that theta as 120 here, okay. So R will become 104.4 newtons, okay. It's coming as the same answer as per the method 1 parallelogram law, okay. Then you can apply sine law for getting the angle of the resultant A, okay. So here we require only 2 terms. We do not want to compare 3 terms. So the required terms are being substituted here. So we get the equation according to sine law. R by sine 120 is equal to 70 by sine A. So here we simplify that this equation for getting A is equal to 35.5 degrees. So that's all about the answer. Both methods, by parallelogram law and triangle law, we get the same answer. So that the method we follow is right. Thank you.